In question 3, we're going to continue to solve logarithmic and exponential equations, but they're going to be a little bit more difficult. For instance, in part A, we have log base 4 of x plus log base 4 of x plus 6 is equal to 2. Before I can get rid of the log, I need to condense it into one log. So with addition, we're going to condense that through multiplication. So this will be x times x plus 6 is equal to 2. Now we can get rid of the log by using the base of an exponent. So we'll have 4 to the log base 4 of x times x plus 6 is equal to 4 to the second power. The base and the log will cancel, and we're left with x times x plus 6, which is x squared plus 6x. On the right side, 4 squared is 16. Normally we just start solving like a normal equation. We do again, it's just now we have a quadratic equation, and in order to solve those, we need to get it equal to 0 first. So I'm going to subtract 16 from both sides to get it equal to 0. Now I can factor it into x plus 8 and x minus 2. So my two solutions would be that x is equal to negative 8 and x is equal to positive 2. But right in the directions, it says to make sure you check for extraneous solutions. And with logarithms, we've got to make sure that we're not going to try and take the log of any negative number. So when I start checking the solutions, I'm going to just take that first x and plug it into the original equation. So log base 4 of negative 8 plus log base 4 of negative 8 plus 6, which is negative 2. And does that equal 2? Well, you try and type that in your calculator and you're going to get a big old error because you're trying to take the log of a negative number. So x equals negative 8 is not a solution. That doesn't necessarily mean that x equals 2 is. We should try that one as well. So plug in 2 for x. Log base 4 of 2 plus log base 4 of 2 plus 6, that'd be 8. And find out if that equals 2. You'll type that all into your calculator, and yes, that does equal 2, so there is our solution. In part B, we have another exponential equation, so we need to get the exponent alone. That's going to involve subtracting 7 first. So we're left with 3 to the 2x is equal to 2. Now, to get rid of the base, we're going to use a log. Log base 3 of 3 to the 2x is equal to log base 3 of 2. The log and the base will cancel, so 2x is equal to, in the calculator, 0.630. Finish it up now by dividing both sides by 2, and x is equal to 0.315. Now it says to check for extraneous solutions, but we have no problem having any type of number as a power. So you can plug this into the original and you'll find out that it works. This last one, and I'm pretty sure there's one like this on a test where we have one exponential expression equal to another exponential expression. And in order to get rid of the base of an exponent, we take the log. So in this case, I'm going to get rid of the 3 by taking the log base 3 of both sides. Remember though, we're going to take the log base 3 of both sides. We can't change that base at all. It has to be the same one. On the left side, the base of the log and the base of the exponent will cancel and leave us with 2x. But on the right side, they don't. And so now we need to use that power property, which says that we can take the power of a logarithm and it'll come down as the coefficient. So here, our coefficient is going to be x minus 10 times log base 3 of 81. Well, now we can calculate log base 3 of 81, and we find out that that's just 4. So now we're back to having a nice easy equation. Distribute the 4. Get all the x's on one side, so I'm going to subtract 2x to bring it over here, and then add 40 to bring it over to the other side. So I subtracted 2x from both sides, and I added 40. Those cancel, those cancel. And that's how we get this expression. So finish it up by dividing by 2, and x equals 20.